Okay, these are the last set of notes that we will deal with, dealing with similar figures. And this set of notes is dealing specifically with similar triangles. So we're going to get into that and then do some of the problems. And then again, I'll give you the review sheet for the quiz. And then just make sure you check the answer key, do all the problems, and then double check your answers. Okay, so there's 3 reasons why triangles are similar. This is very similar to what you did with congruent triangles a couple of months ago, but there's only 3 reasons why triangles are similar. So we're only talking about triangles here, and these only 3 reasons are AA, which is called angle-angle, SSS, which is side-side-side, and SAS, which is side-angle-side. And these are some of the same things that you've seen before, but these are just dealing with similar triangles, okay? All right, so let's talk about the first one, AA. And what that stands for is angle-angle. Remember, if 2 angles in a triangle are congruent, automatically the third angle has to be congruent. So you don't have to have all 3 angles. So if 2 angles of one triangle are congruent to 2 angles of another, then the 2 triangles have to be similar. And remember, if shapes are similar, their angles are congruent, but their sides are proportional. Look at this first triangle here. It's clearly bigger than the second. But if you put it in a copy machine and said reduce it by half or 50%, the angles are still the same. So if we see that this angle and this angle are the same, and this angle and this angle are the same, automatically the triangles are similar. And remember, the symbol for similar looks just like that. All right? All right, so here are some examples. Again, we talked about before some things that are guaranteed in life that you should always know. Vertical angles are congruent. So if I look at this first triangle, triangle 1, and I look at the second triangle, triangle 2, I already know that these 2 angles are congruent. And then I look at these 2 angles, well, they're both 45 degrees, so they're congruent. So automatically, I've got 2 angles that are congruent. So are they similar? The answer would be yes. All right? And a lot of this is just identifying. It's really pretty simple. All right, here's another example. They gave me 2 angles of one triangle and 2 angles of another. So it looks to me like we already have one match here and here. But the 48 and the 75 don't match, but I'm still missing this angle here. And again, what's the easy way to find the missing angle in a triangle? Add them up and subtract from 180. And it looks like this missing angle here is 75. So if this angle is 75 and that angle is 75, I don't even need to go any further. Yes, these are similar because of angle-angle. I found 2 angles that match, so they're similar, angle-angle. All right, let's look at this one. So I see a 90 and a 90. Problem is the 44 and the 47 don't match, so let's find this one here. So we could subtract those numbers from 180. And this angle here should be 46. I think we're going to have a problem here. I could find this angle here, but I don't think it's going to be a 46 or a 44. And that missing angle is 43. So I need to have at least 2 that match, and I don't. So are these similar? No, they're not similar. Okay? All right, another one is called side, side, side. And we're not talking about congruent. We're just talking about similar. You technically did this last week when we did the test to see if any type of polygon was similar. Remember, if any type of shape is similar, the sides have to be proportional. And the easiest way to see if they're proportional is just to divide the 2 numbers. So if the lengths of the corresponding sides of 2 triangles are proportional, then the triangles are similar. So what that means is this side here and this side here should have the same ratio. If I divide those 2 numbers, it should be the same for AC over PR and BC over QR. If they don't all 3 match, they're not similar. Okay, and again, you technically did this last week. So let's go to this one and let's find our match. 6 should go with 15, so let's do 6 divided by 15. So again, just have your calculator, do 6 divided by 15, that's 0.4. Now be careful on this one. Do I match 8 with 20 or 8 with 12.5? Well, look at your two numbers here between 5 and 8. 5 is the smaller number. It should go with the smaller number down here. So 5 should go with 12.5. So if you do 5 divided by 12.5, that's 0.4. Well, then that means 8 must go with 20. And if you do 8 divided by 20, that's 0.4. So are they similar? Yes. Why are they similar? Side, side, side. All right. Now, sometimes they'll give you a triangle that's inside of another triangle. I have the big triangle here, but then I have the little triangle right here. All right. The best way to do this is to just pull them apart. Draw the little triangle first, and then compare them side by side. So it's a 10, an 8, and a 12. Then draw the big triangle. But remember, with the big triangle, you're probably going to have to combine some sides here. 20 is the bottom piece. The hypotenuse, all of that piece right there, should be 12 and 18 combined. So if you combine 12 and 18, that's 30. And then the side piece is 10 and 15, which is 25. Now you should clearly be able to see who goes with who. Who does 12 go with? 12 is the hypotenuse, goes with 30. So do 12 divided by 30, assuming this was the right triangle. So 12 divided by 30 should be also 0.4. 8 goes with 20. Do 8 divided by 20. That is also 0.4. And the last one to check, again, make sure you check all three. Do 10 divided by 25. 10 over 25 is also 0.4. Okay? So again, yes, they are similar. Now, the last one. Side, angle, side. And what this means is one side is proportional to another. The angle must be congruent, not proportional. The angle has to be exactly the same. And the other side right beside it also has to be proportional. And remember, the angle has to be between the two sides. So here they're telling you A and P are congruent. So I'm going to put a mark here and a mark here. And then we're talking side BA or AB over QP. Whatever that ratio is, maybe it's 0.4, maybe it's 0.5, maybe it's 0.75, I don't know. But it should be the same as AC over PR. That one right there. You got to have the same ratio. And again, easiest way to do this, take your calculator and divide. All right? Okay, so it looks like we got another triangle sitting inside of another triangle. But when I pull them apart, they both should share angle A. So I'm going to take this little triangle, which was a 4 here and a 6 here, but angle A was the top part of it. All right, you can put B and E if you want to. You don't really have to. Then I got the bigger triangle, but it had angle A at the top, C at the bottom, and D at the bottom. But remember, A to C was 8 plus 4, which was 12. A to D was 6 plus 12, which was 18. Okay, so again, be careful. They both shared angle A, so you know that's congruent. See what 4 divided by 12 is. What is 4 divided by 12? Well, it reduces to 1/3, so isn't that 0.3 repeating? Okay, who is 6's match? 18? Do 6 divided by 18. Again, it's easiest just to do it on your calculator. That's also 0.3 repeating. Guess what? Two sides are proportional, and the angle in between them was congruent, so yes, they are similar. All right? Again, be careful with this one. I see vertical angles, so they both have angle W in common. But the question becomes, who does 10 go with? The 22 or the 20? Well, between 10 and 11, 10's a smaller number, so 10 should go with the smaller number on the other triangle. So that's 10 divided by 20. That's a half, or 0.5. Well, that means 11 goes with 22. Wouldn't 11 over 22 also a half, or 0.5? So are they similar? Yes. And why? Because the side, angle, side. They shared this angle right here. So you had a side, an angle, and then a side. That's why they're similar, not side, side, side. Let's look at this one. Same thing. Pull them apart. I got the little triangle, but the little triangle has angle A at the top. It's 8 here and 10 here. Then I got the big triangle, It also has angle A at the top, but remember the total piece here is 12, 8 plus 4, and the total piece here, 10 plus 5 is 15. You know they have angle A in common, so let's check 8 over 12. Alright, 8 over 12, that's 0.6 repeating, and then 10 should go with 15. If we don't get 0.6 repeating, they're not similar. So do 10 divided by 15, guess what? It's 0.6 repeating, so yes, they are. The reason why, so yes, they are, would be side, angle, side. Alright? Same thing, are they similar? And if so, state the reason why. Well, I see three sides, but I also see they have vertical angles here. So it could, maybe it'll be side, 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 maybe it'll be side, angle, side, we'll see. So let's try 9. Whose 9's match? Should be 6. Do 9 divided by 6, 1.5. And again, just be careful. 6 is the smaller number in the triangle. It should go with the smaller number of the other triangle. So do 6 divided by 4. That's also 1.5. Only thing left is 7.5 and 5. Do 7.5 divided by 5. That's also 1.5. I did not mean to put a 1 right there. That should just be 1.5. Okay? Okay, so yes, they are similar, but actually there's two reasons here. So if you picked one of these on a test, if you said side, 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 I would count it correct. But you could also say side, angle, side. Why? Because you had this side, then this angle was congruent, and then you had this side here. So either one of these would actually be correct. Okay? It would not be angle, angle, because they did not give you two angles. Alright, a couple more of these and then we'll do the actual problems. Same thing, are they similar? Anytime you see a triangle and a triangle, pull them apart. You got the little triangle, 10 and 12. You got the big triangle. Remember, this side is 10 and 15, that's 25. The other side is 12 and 18, that's 30. Okay? Okay, so 10 should go with 25. And that's 0.4. And 12 should go with 30. Again, just do 12 divided by 30, also 0.4. And remember, when I pulled them apart, angle M was at the top of this one, but it was also at the top of this one. Alright? So they both shared the same angle. So it should be yes, side, angle, side. Okay? Now, last few problems here, you're actually just going to use them to solve the problems. And you've technically done this already, just make proportions. But if it's a triangle inside of another triangle, pull them apart. So I clearly see this triangle here, BEA, and then I got a bigger triangle, CDA. So what I'm going to do is just separate them. I'm going to draw the smaller one first. So there's B, E, and A. And that piece is 3, that piece is Y, and that piece is X. Now I'm going to draw the bigger one. And be careful with the total pieces here. So that's C, that's D, and that's A. Okay, this piece is 3.5 from C to D. This piece is 5, the total. They gave you the total right here, 5. But this is the one that people make mistakes with. This is not 3Y. One piece was called 3, the other piece was called Y. You're combining those pieces, so that's 3 plus Y. And there it is right there. And again, like I said before, find a match that doesn't have any letters in it. X's match is 3.5, Y's match is 3 plus Y. Don't start with that. Start with 3 and 5. If you put 3 on the top and 5 on the bottom, you went from little to big. So if we solve for X, it's X over 3.5. Okay? Now, I'm not going to work every single one of these out. 5 goes with X, 3 goes with 3.5. You can multiply that out. That's 10.5. And then divide that by 5, but X is equal to 2.1. You can work that out on your own. Now, to solve for Y, use the same proportion. 3 goes with 5. Who does Y go with? 3 plus Y. Remember I told you this the other day. Most of these problems are going to involve distributive property. these two go together. That's 5y. But you've got to multiply 3 by the binomial 3 plus y. That's distributive property. Alright, so 5y equals 9 plus 3y. And again, I'd move the 3y over and subtract it. So you got 2y equals 9. Divide that by 2 and y equals 4.5. And there's your answer there. Alright? Alright, a couple more. And again, a lot of these are triangles inside of a triangle. So, x, 12, 20, 16. And that one should be pretty simple. Alright? So, who does 12 go with? 16. And who does x go with? 20. And just cross multiply and divide. 16x equals 20 times 12 is 240. Do 240 divided by 16, x is equal to 15. Okay? Same thing on this one. Pull them apart. I see the smaller one, QMN. 5 here, 6 here. Now draw the big one, PMO. So they share the same angle. But remember, this side here is a combined total of x and 5. That's x plus 5. This side is a combined total of 6 and 3.6. Well, 6 plus 3 is 9, so 6 plus 3.6 is 9.6. Again, find your match. Who does 6 go with? 9.6. Who does 5 go with? X plus 5. You're going to have to distribute again. Alright, so I'm going to go ahead and multiply that out, but that's going to be 6x plus 30 equals 5 times 9.6. So if you do 5 times 9.6, that's 48. Subtract 30. Most of these are two-step equations. 48 minus 30 is 18, and 6 goes into 18 how many times? 3. There's your answer right there. And let's look at this one. And again, just make sure you match it up. Looks like the 8 should go with the 10. And if you started with the 8 on top, x plus 6 should be on the top here. Now you got distributive property, but you got to do it twice. Okay, so I'm going to do these two. So that's 8 times 2x plus 6 equals 10 times, now I got to do distributive property again, x plus 6. So that's 16x plus 48. Is that right? And then the other side is going to be 10 times x plus 6. So that's 10x plus 60. And again, I would move 10x over. And I would move 48 to the right side. 16x minus 10x, I'm going to bring it down here. That's 6x equals 60 minus 48 is 12. How many times 6 go into 12? X is equal to 2. Sometimes they come out perfect, sometimes they don't. Alright? And last slide. Again, this one should be easy to match up. This is exactly what they'll look like on the quiz. 10 goes with 4. So if I put 10 on top, 2x plus 10 needs to be on top. And that'd be x plus 3. Distribute here. I'm going to go ahead and distribute it. That should be 10 times x is 10x. 10 times 3 is 30. And I'm going to distribute this one here. So that's 4 times 2x. That's 8x. And 4 times 10 is 40. Bring the 8x over. And bring the 30. And 2x is equal to 10. How many times 2 go into 10? X is equal to 5. And there's your answer there. Alright, don't forget, look for any open assignments, whether it be today or tomorrow, depending on which day you're looking at this video. Don't forget, make sure you turn everything in And again, show all your work,